So, thinking back to Bohr models, we found out that these electron shells or the energy levels that the electrons would move around in, but it's a little more complicated than that. It's not like we have these perfect circles where electrons are just rotating around the nucleus. Within each of these energy levels or shells, we have sublevels, which are regions where an electron is most likely to be found. And today we're going to dive a little deeper into that. There are four different types of orbitals that we're going to talk about. They're given different letters, S, P, D, and F. S orbitals can hold 2 electrons, P orbitals can hold 6 electrons, D orbitals can hold 10, and F orbitals can hold 14. And this is actually aligned with the periodic table that you'll see a little later on. When we're drawing electron configurations, it's really important to remember 3 basic principles. The first principle is the Aufbau principle. It is a German word that means building up or construction. And with Aufbau principle, we need to start with our lowest orbitals first and then make our way up. So this one's kind of hidden behind the screencastify sign, but this bottom box is 1s. So first we would start with 1s, we would move up to 2s, we would move up to 2p, we would move up to 3s, 3p, 4s, 3d, 4p, and so on. We start at the bottom and we work our way up. With Pauli exclusion, it says that each box can hold up to 2 electrons, but these pairs of electrons have to spin in different directions. So if 1s has an electron which we show with an arrow spinning up, then the other one has an arrow spinning down. So each box can hold 2 arrows and they have to spin in opposite directions. Our third principle, Hund's rule, says that orbitals get 1 electron first, and then they pair up by getting a second one if they need it. So when we're filling it up, we would only put 1 electron first. So for example, if we needed 3 electrons, each box would have 1, giving us 1, 2, and 3. If we needed 4, then we would start doubling up, 5, double up, 6, double up. So quick check for understanding, if Kayana adds 2 arrows to the 1s orbital facing up, so this is 1s at the bottom, I'm actually going to mark this out and say 1s is here so you can see it. And it's saying she has 2 electrons going up. Which rule does this violate? This would be the Pauli exclusion principle, which says we have to have opposite spins, 1 up and 1 down. Our next one, Kevin starts adding arrows to the 3p orbital. So he starts adding electrons here instead of starting at the bottom. So which principle is he violating? It would be the Aufbau principle, which says we have to start at the lowest level and work our way up. And our next one says that Lachelle adds 2 electrons to each box all the way up to 3s, instead of adding 1 electron to each box of an energy level first. So what does this violate if she's adding 2 electrons all the way up instead of adding 1 to each box first? That would be Hund's rule because it says we only double up if we have to, but we add 1 electron to each box first. And we're going to go through some examples where we do this together. So nitrogen has 7 electrons. This 7 comes from our atomic number. We're looking at all electrons, not just valence electrons. So we need to draw 7 electrons with arrows. Aufbau says we start at the bottom and we're going to work our way up. We start with 1 arrow first according to Hund's rule, and then we add our second one, and according to Pauli, they have to have opposite spins. So 1 up, 1 down. We move up to our next level. We have 1 up, 1 down. We have a total of 4 electrons, but nitrogen needs 7. So we move up to our next level. Hund says we add 1 electron in each box first. So this is our 5th electron, this is our 6th electron, and this is our 7th. Nitrogen only has 7, so we're actually done now. We don't have to double up because we don't need any more. If we look at chlorine, on the periodic table, chlorine has an atomic number of 17. So we have 17 electrons that we're going to draw. We start at the bottom. Aufbau says start at the lowest position. 1, 2. Again, Pauli says 1 spins up, 1 spins down. We move to the next level. 1 up, 1 down. We have 4. Still need to keep going to get to 17. Move to our next level. 5, 6, 7. Now that each box has 1, Hun says we double up. 8, 9, 10. We move up to our next level. 11, 12. Keep going up. Now we go to 3p because it's the next highest. 13, 14, 15, 16, 17. Again, our 3 principles, we start at the bottom and work our way up. We put 1 electron first and add a second one if we need to. And we always have 1 spinning up and 1 spinning down. And if you notice, I just do half arrows. This is the same as actually saying this, but I find it a little quicker to do the half arrows. And our next one, if we look at the periodic table, argon has 18 electrons, has an atomic number of 18. Start at the bottom. 1, 2, 3, 4, 5, 6, 7. Whoops, sorry about that. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Again, just need to make sure you're keeping in mind your 3 rules. Aufbau says you start at the bottom and work your way up. Pauli exclusion principle says 1 arrow goes up, 1 arrow goes down. And Hun says you add 1 electron first, and then you go through and add the second one if you need them.